Hello, welcome to Introduction to Data Science. I'm Jay Kumar from GoGuru.com. So in today's session, this is the agenda that we have. We are going to cover a couple of things. We're going to cover what is data science, machine learning, deep learning, artificial intelligence, and difference between analysis versus analytics, and the different types of analytics. So let's get started with what is data science. So for new people, the term data and science may look little different. What does data got to do with science? So if you look at it, as you know, data can be like raw information that doesn't make much sense by itself. But when you combine data from different sources, or if you correlate data, then you kind of get a lot of insights from it. That is what data science is about. Data science is about looking at all this information and trying to extract meaningful information out of it, insights from out of it, and that too from many structural and unstructured data. So what does structural data mean? Structural data means something which is organized in a way, such as it could be a CSV file, it could be a tab delimited file, it could be a database, or could be in Excel, something like that. Unstructured data is data that is not structured in any format. For example, if you think about a Word document, it's not structured. People could use different interpretations of it. Some could have all text, some could have images, and then that you could have all different kinds of Word components within it. And then audio files are one examples, looking at the blog data, and then video files, they're all examples of unstructured data. So data science is really trying to look into both types of data, that is organized data and unorganized data, and trying to get meaningful information, extract insights from it. And it is mostly used in the fields of data mining and big data. When you say data mining, in a sense, you look at the patterns within data and try to extract meaningful information out of it. And it is not just by itself, because data science is a huge thing, and it involves the discipline of multiple fields, like in mathematics, statistics, which includes probabilities, and computer science and information science. So this is overall what is data science. Now we'll go on to what is machine learning. So machine learning is actually an AI technique that is used for processing big data. When I say big data, how big it could be? Like previously, we were like talking in terms of kilobytes, and then we moved on to MBs, and then we moved to GBs. This is like terabytes or a couple thousand terabytes. So that is what a big data is. So what we're using machine learning is, we're trying to process big data, information data that is so huge, using self-adaptive algorithms. The difference between regular algorithms and self-adaptive algorithms is, the self-adaptive algorithm tries to learn as it sees more data and gets better at analyzing things. So the more data you feed, it learns from the data and it gets better with experience or newly added data. So that is what machine learning is. So machine learning can be employed in different fields. And in this example that we have here, it can be used for detecting fraud in a system. Like, for example, you could use it for a credit card transaction. Company can use it to point out outliers within the purchase, to find out like, okay, there is a purchase that happened. The customer is the card owner is in the US, but there are some transactions happening in India at some odd hours, which is like really deep in the night in the US, but it's happening in India. So the credit card company can stop it and even decline the transaction, or give a call to the customer to find out if he can authorize it. So those are the things that machine learning can help. And then we move on to what is deep learning. So deep learning is actually an AI function, the artificial intelligence function, that tries to mimic the way the human brain processes data and patterns. So the way that we process data is like mostly in terms of, for an example of a flow chart, or making a decision tree where we go through a logic of true or false. It is very similar to that. It follows that to mimic the human pattern, thinking pattern, and it uses a lot of unsupervised data. Unsupervised data in the sense there are two types of data, algorithms that it can learn from. One is supervised and unsupervised. Unsupervised is something that without any supervision or without any training or teaching, you let the program find stuffs automatically. It is pretty much equivalent to self-learning. That is, you either go to a trained tutor who teaches you stuffs to recognize some things and get the knowledge, which is called supervised. And unsupervised in the sense you're letting the algorithm learn by itself. I don't know what you're looking at, just try to see if this makes sense or pick some information out of it. So that is what unsupervised data is. So unsupervised data from unstructured data, which is pretty tough. And then the fields that deep learning can be employed is in terms of computer vision, speech recognition, natural language processing, audio recognition. So when you think about the audio recognition itself, you can make your computer recognize certain voice patterns from literally thousands of millions of voice records. So one example is when the wiretapping, where they try to recognize some common voices and see like what's going on between them. So this is pretty much what deep learning does. Then we move on to AI. AI is a very interesting field. It's been there for several decades now, but it has recently gained popularity in the very recent times. So what AI does is it is making a computer or a robot or any software for that matter, for piece of software that you write, you make it think like an intelligent human being. So that is the concept of AI. Basically, you're trying to make the program think like an intelligent human being, the way that he looks at things, how he works through a problem, how the skills that humans do in terms of solving problems. And then you basically use the output of it to build intelligent systems. That is what the AI does. AI is used in the fields of logistics, data mining, medical diagnosis, where doctors, if they have some difficulties, they can feed a couple of x-rays or other scan results, and the computer, as it looks through it, it gets better and better and better, and it can easily predict things out. And then we come to the concept of what is data analysis and the difference between data analysis and data analytics. So the main difference is data analysis, in short, is a portion of data analytics. That is all. Because with the data analysis, what you're typically doing is you're trying to look at the data, then you kind of transform it or arrange in a certain manner that you want, and you try to get some meaningful information out of it. This is what data analysis does. But data analytics is a wider field where it in addition to what data analysis does, it also does the task of collecting the data, organizing the data, storage, and the tools that are involved. The tools that could be involved is it could be algorithms or other scientific methods or mathematics that could be applied. So combined with all the tools and the organization of data, everything makes what is called data analytics. Then we move on to what is the data analytics, and there are different types of data analytics. So why do we need data analytics in the first place? So as you know, there is a lot of things about the data. We are generating a lot of data these days, and we're commonly used to the term that data is the new oil. So people are looking at data to find interesting insights from it. And there is data available in such a huge patterns and sources from everywhere. So we are trying to look at the data and see if what we can find from that data. So in order to do the type of analytics, we have like 4 different types of analytics. The first one that we'll be looking at is descriptive analytics. So descriptive analytics is something that tells what is happening in the business. So this is after you process it through an algorithm, it tells what is happening. That's all. It doesn't explain the reason why. And the information that we find out, sometimes it could be right or it could be wrong. That is why what we need to do is we need to combine descriptive analytics with other 3 or we have 3 more analytics. So we need to combine this with other analytics to find meaningful information. For example, using descriptive analytics, you can find out what is happening. For example, what made the sales of a certain bike model go down this month, and we did not reach our expected sales volume. We are down 7%. So it tells you like what happened. That's all. What happened. And then another example could be we expected to bill our clients for 2,000 hours, but we only did 1,800 hours. So those are the information. It just tells what happened. That's all. You don't know why. So with that question, then you go to the next state of analysis to find out. The second state is diagnostic analytics. This gives us the reason why it is happening in a business. So what we can do is basically in this stage, we try to combine data from different sources. You can maybe look at historical data and find out why certain things are happening in your business. For example, just like what we did in the what is happening, the why could be answering our questions like the reason why our bike model sales was down is our competitor released a model that is better compared to our model, and it also includes a 3-year service. So that could be the reason why our bike model sales was down. And the second one is using what we could have predicted that we did not reach our sales volume since it was down 7%. But our analysis could find out that our primary supplier recently had a recall issue, and while he was busy fixing the recalls, he didn't have the capacity to deliver our target. So that is why our sales was down. So these are the things that diagnostic analytics can tell us. And the third one is very interesting, which is predictive analytics. It tells what is likely to happen in our business. So again, in order to find this type of research, we need quality data, very quality data, reliable data to predict what has happened in our business, to what is likely to happen. And based on that prediction, we can make some forecasting and then appropriately adjust whatever needs to be done. So an example of like how likely or something is supposed to happen is, for example, that could be a question based on the last 2 years income report. What will be my income this December? That could be one question you can make the system, ask the system to predict. And then you can say, going by the recent resource challenges, will we be able to complete the project in 6 months? So you need to ask the model to see if it can get the answers for you. And finally, this is prescriptive analytics. Prescriptive analytics is even more intelligent. It tells you what kind of action you need to take. So different companies can use it in different ways. For example, e-commerce companies can use the analytics to take advantage of either a problem or an opportunity that they can exploit. So some of the questions that the company can ask and find a prescription for it is, based on the last 2 years of income report, our December revenue is expected to decrease as it's a slower month with a lot of holidays. So what should I do to make that sales higher? So this is one question that you can ask. Then you can take a look at the pattern, saying that a customer, Netflix can use it, for example, to find out a customer has seen a movie from thriller type. Should I give him a suggestion for a similar thriller movie, or should it be a sci-fi? So based on that, the model can run different diagnostics, and it can give a recommendation saying what kind of a movie this customer may be interested based on the likes of similar customers. So these are the things that predictive analytics can come in and help. So with this, we end our session today, and I hope it was helpful to you. Thank you. I'm Jay Kumar from GoGuru.com.